squared plus 20t. Of course, time is greater than or equal to 0. At what time does the particle have a velocity of 20 meters per second? And at what time is the acceleration 0? And what is the significance of this value of t? Significance. Okay. So they're asking us when is the velocity? When? When means what time? When is the velocity 20? What do I have to do? To find this time.
Let the derivative equal to 20.
Very good. V of t or s prime of t equals 20. Perfect. So let's find s prime of t. Polynomial function, very simple, right? 4 t to the third minus 12 t squared minus 40t and plus 20. So we are setting this equal to 4t cubed minus 12t squared minus 40t plus 20 equals 20. I will factor out 4t, t squared minus 3t minus 10. Yes, I can solve this as I showed last time, and I forgot. I just realized now I forgot to post that video. I have to post it tonight. That I showed you the how to use the feature, the calculator. Okay, so no problem here. 4t, t minus 5, and t minus 2, t plus 2 equals 0. So from here, of course, 4 cannot be 0. So here we have three solutions. T equals 0, t equals 5, and t equals -2, which is not possible. They're telling us that t has to be greater than or equal to 0. So this is not possible. Okay, good. So seconds and seconds. So the velocity is 20 at time equals 0 initially, and also 5 seconds later. Now in part B, they're asking us when is the acceleration 0? At what time is the acceleration 0? So at what time does the particle have a velocity of 20 meters per second? At t equals 0 initially, and at t equals 5 seconds, 5 seconds later. Okay, so now how do we find the acceleration?
Derivative of the velocity.
Very good. So I have to differentiate this. So I have 12 t squared minus 24t and minus 40. And now I have to set this equal to 0. 12t squared minus 24t minus 40 equals 0. And of course, I will divide everything first by 4. 3t squared, 6t minus 10 equals 0. We can factor this. It's -30 and -6. 10. Okay. Can I factor it? So -30. I need two numbers whose product is -30 and whose sum is -6. So 6 and 5, 10 and 3, 15 and 2. Maybe not. Okay, so let's do that. And we go to the apps. Yes, we can use the quadratic formula, but why should I? Can I go directly here? Yes, it's still degree 2. Yes, the first coefficient is 3. The second coefficient, oh, look at that, it's -6. Nice. And the last one is -10. but no, that's not good. This is good. Okay, and I want to solve. Okay, so I cannot accept the first one because it's negative, but I will accept the second one as x, not x, of course, t equals 3.08 seconds. So the acceleration is 0 in 2 different points, but I can, for 2 different t's, but I can only accept the positive t. T is greater than or equal to 0. So at 3.06 seconds, the acceleration is 0. And they're asking us to think about what is the significance. It says, what is the significance of this value of t, of this 3.08? So 3.08 seconds. So the particle starts at 0, t equals 0, and the speed is 20 meters per second. And also at t equals 5, the velocity at 5 is also 20. But in between somewhere at 3 points, so t equals 3.08, the acceleration at this point, at 3.08, is 0. Okay, I just presented the whole thing. It doesn't mean that it has connection. I just wanted to summarize our findings so far. So what do you think this represents? At t equals 3.08, the acceleration is 0. What does that mean? If the acceleration is 0, what happens to the velocity?
Remains constant.
Yes. Uniform motion. Constant. Constant at that point. In other words, if the speed is 10, it stays at 10 at that moment. Good. Do you think we are okay with this section? Okay, I know we only have about 20-something minutes. I'd like to start section 3.9. This is not a difficult section, but it has multiple types of problems, really multiple. It's called related rates. So first of all, let's analyze what this means. Related means they happen at the same time. I'm not saying with the same intensity, not same level or intensity. I'm only saying that something happens, different things happen at the same time. They are related. What does this mean is rates of change, right? Motion, in other words, rates of change, derivatives. That's what we're talking about. And when we put these two together, we really think in terms of derivatives or changes that happen at the same time. They are related, and they are normally related to an equation through an equation. Otherwise, they will not happen at the same time if there is no connection. So they are connected, they are related through an equation, connected rates through an equation, and their changes, the changes of those variables, if you want, or derivatives, happen at the same time. Okay, here's an example. Again, I'm going to talk about that balloon. So if I inflate a balloon, what changes? Volume, surface area. Assuming it's a sphere eventually when it's completely inflated. Radius, diameter, and so on and so forth. So all these change at the same time, not with the same rate, but they change at the same time. So then V prime, S prime for surface, R prime for radius, D prime for the diameter, all these will be connected. Of course, not all at the same time. There are certain relationships, etc., etc., but they have a connection. If I'm looking at the volume and the radius, they have a connection. If I'm looking at the volume and the diameter, they have a connection. So these changes will happen at the same time because their variables are connected. They are connected through an equation, so will their derivatives. So if I say that the volume is 4/3 pi r cubed for a sphere, dV would be related with dr, because both will be functions of time. So this is a sphere, this is the volume of a sphere, and I pump air in a sphere. This is a function of time. This is a function of time. So V prime and R prime will also be related through an equation because they are related, their functions are related. V of t and R of t are related. V prime and t and R prime will also be related. This is what we're talking about when it comes to related rates. That's the bottom line, and now I want to practice. We're going to look at all sorts of problems. For this section, I need at least a full full meeting. We do not cover 3.8. That was covered in algebra. So we skip in calculus 3.8. And related rates. Okay. Okay, I'm going to start with 6. Let's start slow. And then I'll let you choose the next one. Which page am I on? I'm on 10. So number 6. The length of the rectangle is increasing at a rate of 8 centimeters per second. The length of a rectangle is increasing at a rate of 8 centimeters per second. Let's stop and let's analyze what this represents. So the length of a rectangle is changing at 8 centimeters per second. What is this? Let's assume that the length is denoted by L and time is denoted by T. Why? L corresponds to 8 centimeters and time corresponds to seconds. So what could this be? L is changing at a rate of 8 centimeters per second. I automatically know that the length is measured in centimeters. I automatically know that the time is measured in seconds. But what would this be that is represented by 8 centimeters per second? It's okay if you're wrong. Just give it a shot.
Velocity.
Yes, which means dl over dt. The rate of change of length with respect to time, which is indeed the velocity, if you want, the rate of change of length with respect to time. But in this case, this is the rate of change of length of the rectangle with respect to time. Now, this is another situation in which we are not going to use L prime. Is it wrong to use L prime? No. No, it's not wrong, it's not incorrect, but we don't. This is a much better notation because L prime doesn't tell me much. This one tells me that L is a function of time and its rate of change is 8 centimeters per second. Okay, next. And its width is increasing, so it's increasing, so that's why I wrote positive. The word increasing made me write positive 8 centimeters per second. Its width is increasing. The word increasing is telling me that the rate is positive at 3 centimeters per second. So can anyone tell us what 3 centimeters per second represents? And I will put it right here in front.
dl dt.
The width. Good. So the width, width, length. Good, awesome.